Brayden, why are you late? Oh. Okay, so today we're going to talk about how you add and subtract in scientific notation. So there's a few rules that we need to know when we add and subtract in scientific notation. The first one is when we add or subtract numbers in scientific notation, they have to have the same power. They must have the same power. It's kind of like when you're adding fractions, you know how they have to have a common denominator? It's kind of the same thing. They have to have the same power in order to add them. Okay, so kind of the steps for doing this is if the numbers do not have the same power, you need to rewrite them so that they do have the same power. So if necessary, rewrite the numbers to the same power. And sometimes you don't have to do that because sometimes you'll be adding or subtracting two numbers that are already to the same power, and then you can skip step one. Okay, step two is pretty easy. You just add or subtract the first factors. Add or subtract the first factors. And when you do this, what I mean by the first factor, if you have a number such as 2.3 times 10 to the fifth, 2.3 is one factor, 10 to the fifth is the other factor that together form a number that you could write in standard notation. So that first factor is the number that's not the 10 to the power. So just add or subtract them. And then sometimes after you add or subtract them, you end up with a number that's not in proper scientific notation. So again, this is an if necessary. You may have to rewrite your answer, rewrite to proper scientific notation, which is 1 digit to the left of the decimal. This is all the writing you have to do. After this, it's just examples. Here's our first example. So if we have something like 2 times 10 to the 8th plus 7 times 10 to the 6th. We can't add them together as they are written because they are not to the same power. So we have to rewrite one of them to make it the same power. I usually end up rewriting the second one. It really doesn't matter which one you pick whenever you're adding. When you're subtracting, it kind of does matter which one you pick because you don't want to end up having to subtract a larger number from a smaller number. So I'm going to change the second one. So I'm going to leave the first one as is, 2 times 10 to the 8th. Now if I want to make this 10 be to the 8th power, I'm going to be moving it up 2 powers. So what do I need to do to my decimal here? Which way do I need to move it? There's no down, it's left or right.
Point to the right.
No, not to the right. Because if I'm taking this number up 2, I'm making it bigger. So if I'm making it bigger, I have to make this one smaller. So I have to move my decimal 2 to the left. So this would be 0.07 times 10 to the 8th. That's the same number as 7 times 10 to the 6th. If we have 7 times 10 to the 6th, that's 7 with 6 zeros. 4, 5, 6, 7 million. If we have 0.07 times 10 to the 8th, I'm going to move my decimal over 1, 2, 3, 4, 5, 6, 7, 8, which results in 6 zeros. We don't need a 0 at the beginning. So it's the same number, we're just showing that we're adjusting the decimal place differently. Now I just add my first factors. So 2 plus 0.07 is just 2.07, 2 and 700ths. The 10 to the 8th part stays the same. It's like when you add fractions and you keep the denominator, you keep the second factor, the power of the second factor. And this one we do not have to adjust at the end because it's already in proper scientific notation. Okay, let's look at an example of subtraction. Change colors here. Okay, 4 times 10 to the, what's that number I've written down there? 8 minus 3 times 10 to the 7. Okay, what's the first thing I need to do? Brayden? Make them the same exponent or same power. So I'm going to switch definitely the second one for this one. What can I rewrite this to in order for it to be 10 to the 8th power? 7? Good. 0.3 times 10 to the 8th. And then I just need to take 4 minus 0.3. What's 4 minus 0.3? 3.7. So I have 3.7 times 10 to the 8th. And again, I don't have to change that one. Question?
Whenever you're like converting it to the power, like making them think, you have to make it, say it's 6 and 2, you have to make it 2 to the 6. I mean,
No, you could change it the other way too.
oh, so
Yeah, it doesn't matter which one. Right, like we could have changed this 2 times 10 to the 8th on the first example. We could have made that be 20 times 10 to the 7. And it would have worked also. Then we would have added, we would have gotten 20, let's see. We would have gotten 207 times 10 to the 6, and then we would have changed it to proper scientific notation, and we would have gotten the same thing.
Oh,
Okay, so when we do the examples that you guys are going to do, some of you may choose to change a different one, and then we can talk about how that works. All right, let me give you guys some examples now to try. Here's the first one. And the second one. Okay, go ahead and take a couple minutes to try these examples and then we'll talk about them. Over this, I'm not going to use the card since we have so many people missing today. So I'll volunteer for number 1. Tell me how you did it. Go ahead, Reagan.
I would change the second one to 0.2 times
Okay.
to the third.
Okay.
And then end up with 3.8 times 10 to the third.
Okay, good. Did anyone do it a different way? No? Everybody did it the exact same way? Okay, good. That's fine. You could also have moved could have done 40 times 10 to the second. That would have been more work because you would have had to have changed it at the end. Dakota, are you volunteering for the next one?
I changed the first one to 0.09 times 10 to the 7 plus 6 times 10 to the 7, and I got an answer of 6.09 times 10 to the 7.
Wait, 6.09? Yeah. Wait a second. If you change the 9 times 10, yeah, that's right. Times 10 to the 7.
What would the answer be if it was fifth?
Let's do it the other way. Did someone change it?
Yeah, I did.
It would be a different answer.
Okay, something, wait, let me think about this. Something's wrong up here.
I got 609 times 10 to the fifth.
Okay, tell me how you did it the other way. Jake, you did it the other way?
No.
No? Who
But I
did
was
it the
looking
other
at
way?
it the other way.
Zoe? What did you do?
609
Okay, so wait a second. So what did you change? Let's go step by step. You changed the... Okay, so you changed it to 9 times 10 to the 5th plus 600 times 10 to the 5th. Okay, good. You can do it that way. So then the answer you get is 609 times 10 to the 5th, okay, which is technically correct, but it's not in proper scientific notation. We need to move our decimal over 2 places, and then we need to move our scientific notation up 2. So it still works out to be the same answer. It may look different at first, but don't forget that step 3 that you just copied down in your notes, that if it's not in proper scientific notation, you do have to change it to proper scientific notation.
So if you want to avoid all that, you could just go with the higher power and try, like, in this case, we went to the higher power. 7.
Yeah, it works better. Ross just pointed out a really good thing. If we pick the higher power and go to the higher power, we're less likely to have to rearrange at the end. And a lot of you did that intuitively. All right, we're going to look at a couple more examples that have some negative numbers in them, because we do have negative scientific notation sometimes. So let's do 1.8 times 10 to the negative 2 plus 5.9 times 10 to the negative 4th. All right, volunteer to tell me what I should do first. Jake.
You change the -2 to a -4, or the -4 to a -2.
Okay, which one do you want to do?
Well, I'll do the -2 to a -4.
Okay, so we're going to change this to a -4. If we change this to a -4, did we make it smaller or did we make it bigger?
You made the number bigger, didn't you?
No, we're changing it. Remember, the negative power is telling us how many times we move the decimal left. Every time we move the decimal to the left on a number, it's getting smaller. So if we're now moving the decimal 2 more places to the left, what do we have to do to this number to balance it out?
To the right.
We have to move it to the right. How many places? 2. So we have 180 times 10 to the negative 4th plus 5.9 times 10 to the negative 4th. So we add our first factors together. We have 185.9 times 10 to the negative 4th. Now I have to change that because that's not in proper scientific notation. If I move the decimal so that I have 1 digit to the left of the decimal place, what is my result? Violet.
1.859
Times what?
Second.
Good. Give me a second. All right, any questions about that? Let me give you one to try. Let's do 3.9 times 10 to the negative 2 minus 5.1 times 10 to the negative 3rd. All right, give that a try and then we'll talk about it. All right, any volunteers to walk us through this one? Scott.
I do the next step for 39 times 10 to the negative 3 minus 5.1 times 10 to the negative 3.
Okay, so you change from both to the negative 3rd minus Okay, so Guy chose to change the first one. You could also have chosen to change the second one. It doesn't matter. She moved her decimal one to the right, and so then made this smaller, which resulted in a number with a larger absolute value. Okay, and what did you end up with?
Got 33.9 times 10 to the negative
33.9. That's not what I ended up with. Maybe I did something wrong. Anybody else do something different? Zoe?
I got 3.09.
That's not. Hang on a second. That would be. What did you get again?
33.9 times.
That's actually right. That's right. Okay, so 33.9 times 10 to the negative third. Now that's not proper scientific notation. What would it be in proper scientific notation? Devin?
3.39 times 10 to the negative second.
Good. 3.39 times 10 to the negative second. Okay, any questions about that? Be careful, guys, when you are doing your math without a calculator. If you're doing 39 minus 5.1, remember you need to line up your decimals, so you have to put a 0 here. Turn this into a 10. 10 minus 1 is 9. 8 minus 5 is 3. And 3.
I had to redo this one. I made it 3.09 and I did it that way.
Oh.
I had to redo it.
All right, we're going to look at just a couple additional examples. We're almost done here. The next example we're going to look at is one where one of the numbers is in scientific notation and the other number is not. So we have 4.9 times 10 to the negative fifth plus 0.0005. So when we have two numbers that one is in standard form, one is in scientific notation, they both have to be in the same form to add them. So we could convert the number in scientific notation to standard form and then line them up and add them that way, which is actually easier, I think, if we write them both in scientific notation. So I'm going to bring this one down. It's going to stay the same. What does this number become in scientific notation? Zoe?
5 times 10 to the negative 4.
Good. 5 times 10 to the negative 4. Okay, now I need to change them to the same power. Reed, what power should we change them to? Change them both to negative 5 or both to negative 4? Totally up to you. Okay, both to negative 5. So we'll keep this one the same. Reed, what would this number be if we take this one to the negative 5 power?
It would be 50.
It would be 50. Good. 50 times 10 to the negative 5. And when we add them together, what do we get? Kayla, what do we get when we add them together?
54.
Good. 54.9 times.
5 times the negative 5.
Okay. Pat, is that in proper scientific notation?
No.
Can you put it in proper scientific notation?
5.49 times 10 to the negative 6.
Well, you just made, yeah, negative 4. Okay, any questions about that? Nope. One more for you to try, and this will be our last one. I'll write the problem down here at the bottom, and then I'll start a new page after. But this way you guys can copy it down. So 4.9 times 10 to the 4th minus 8,200. All right, so that's your next problem. Go ahead and give it a try. We'll talk about that one. This is our last one. Any volunteers? Okay, Jake?
All right, 4.9. Oh, wait, you already have it written. Never mind. Yeah, so I kept the first expression the same,
Okay.
and then I converted 8,200 to 8.2 times 10 to the third power. And then I made the second expression, well, yeah, I kept that one the same, and then I converted the 8.2 times 10 to the third power to 0.82 times 10 to the fourth power.
Good.
And then I subtracted 4.9 minus 0.82 and got 4.08 times 10 to the fourth power.
Good. Okay. Any questions about that? All right, your assignment for today is going to be 2 parts. The first is Khan Academy. I was going to give you paper homework, but I don't think I will. I think you'll have enough with the Khan Academy. And then also you're going to get on Study Island. Start with the Khan Academy because the Khan Academy is already loaded and it's just adding and subtracting scientific notation. Study Island is all kinds of scientific notation. So